In this video, we're going to look at a very interesting question. Problem: in how many different ways can 7 identical notebooks be distributed among 4 different students so that each student gets at least 1 notebook? Later, you will know that this question is a classical question in combinatorics, combinations and permutations, and there will be a standard way of doing it. But before we learn that, I want to here illustrate a very powerful method of solving these questions. And the method is just by doing simplification. If you see a problem that you find is difficult to do, you should always think, can I simplify the problem and solve a simpler version of the problem? And hopefully by doing that, you will find some pattern or get some ideas how you should do the problem at hand, or a more complicated version of the simplified problem that you just solved down. Okay, let's see how we do this. So in how many different ways can 7 identical notebooks be distributed among 4 different students? So one way of simplifying this question is, instead of consider 4 different students, let's consider fewer students. So let's look at, first, instead of 4, let's consider there's only 1 student. And the question becomes, in how many different ways can 7 identical notebooks be distributed among 1 student so that each student gets at least 1 notebook? All right, that, of course, is a really obvious problem. It's very simple. In fact, instead of 7 identical books, let's consider n identical books. And n is bigger than or equal to 1. And clearly, there's only one way. You just give all the books to that 1 student. All right, so this is a trivial case. Now, instead of 1 student, let's consider there are 2 students. And again, there are n books. How many different ways? Now, we use casework. For the first student, if you get 1 book, then all the n-1 books going to the second student. If you get 2 books for the first student, then all the n-2 books going to the second student. So clearly, and so on. So clearly, the first student, if the first student get 1 or 2 or n-1 books, each way corresponding a different way of distributing those books to among the 2 students. So totally, there are n-1 ways. Remember, this n-1 ways is basically I have n books and 2 students. And again, this question is pretty simple, right? If you just look at this question at the first, how many ways I distributed n books to 2 students, it's very easy to arrive this solution. n-1 ways, because the first student can get either 1, 2, or 3, and then afterwards it's just determined. Okay, now the third case is slightly more complicated. Let's say there are 3 students and n books. The idea is, again, we're going to consider the casework for the first student, and then we're going to use the result that we already got of the number of ways distributing n books to 2 students. Because once you distribute the number of books to the first student, the remaining problem becomes distributing the remaining books to the other two students, right? And that will be a problem for the second case. Let's see. If the first student gets one book, so the problem now becomes we need to distribute now n minus 1 books to two students. By the result we already got from case 2, if n books given to students, there are n minus 1 ways, then for n minus 1 books to two students, we have n minus 2 ways. If first student gets 2 books, then we're going to distribute n minus books, because that's the remaining number of books, to the other two students. And this, again, by using the result in the case 2, we have n minus 3 ways. And similarly, if the student gets n minus 2 books, then the remaining 2 books to the other two students. There's only one way. Notice that there's this pattern going on. If there's n minus 2 books, there are n minus 3 ways to give it to two students. If there are 2 books, there are 1 way. So the difference always is 1, right? That's a way you kind of checking your answer. All right, so that means if I summing up all those different ways, that's exactly the total number of ways for distributing n books to 3 students. And the result that would be n minus 2 plus n minus 3 plus all the way to 1. And that, of course, using the summation formula for 1 plus 2 plus all the way to a positive integer, that equals half of n minus 2 times n minus 1. And again, doing this sum is, remember that you just can reverse the total numbers and then you pair them together. Look at this formula. All right, remind yourself what this formula is. This formula says that this is the number of ways of distributing n books to 3 students. So we have done this case. Now let's come to the final case that we want to solve, the problem that at hand. For 4 students and 7 books. Of course, we can actually solving for any n books, but this problem is only for 7 identical books. So let's do 4 students, 7 books. Again, we're going to do the casework of how many books the first student get, and then using the result we already got for 3 students of arbitrary n books, we have this formula using that result for the casework. All right, case number 1, if the first student gets 1 book. So the total number of ways for this case is going to distribute the remaining 6 books to the other 3 students. And because of case 3, we know that this is the total number of ways, okay, for n equals 6. So this total number of ways is going to equal half times 6 minus 2, 6 minus 1, 6 times 5, equal 15 ways. N equals 6, so 4 times 5, equal 10 ways. If the first student gets 2 books. In this case, we're going to distribute the remaining 5 books to the other 3 students. And the number of ways is, again, using this formula. Distribute n books to 3 students is this formula. So distribute the 5 books into 3 students is going to be half of 3 times 4, 6 ways. First student get 3 books. So that will be 4 books go to 3 students. Number of ways equals half times 2 times 3 equals 3 ways. And finally, if the first student gets 4 books, then the remaining 3 books goes to 3 students. And clearly, there's only one way because each one gets 1 book. So the total number of different ways is going to be adding all those things together, 10 plus 6 plus 3 plus 1. Total number of ways is 10 plus 6 plus 3 plus 1 equals 20. Okay, let's review a little bit what we're doing here. We do this problem by simplification. Every time that you see a difficult problem, always thinking about trying to simplify this problem. Make it as simple as possible that you get a handle of it. And by solving this simpler problem, you can gain a much better understanding of the problem. And sometimes you'll see the pattern. Sometimes you really grasp the idea of the problem, and then you will come up with the right approach for the original problem. And this is the most powerful method of solving any problems.